Now we will see you know how is there is one concept called rack awareness. Okay, now we need to check. So MapReduce is also one thing that we will cover later. So today the whole thing was dedicated to HDFS only. Okay, so it will give some idea about like how the HDFS is working, and why it is so famous. So there is something called rack awareness. Uh,
What is that? Rec awareness.
yeah, I'm just telling you, rack
Sorry, I can understand.
awareness.
Okay.
Okay, so what does rake awareness means? So this is one concept basically that is getting utilized in. This is basically more related to block placement policies. Okay, so we know that there are number of nodes, right? Number of data nodes. Now, what to choose? Which data node to choose? To place the copy of block basically. Now, in production, basically, what happens is you don't have individual nodes like that. You basically have the racks, and in these racks basically you will have nodes installed, or nodes actually captured. So if you look into any server room, what you will see that there are racks, and then every rack there are some rack servers. Okay, so these are like kind of these shelves you will find, and there in each cell basically there is one server, and in our case it would be one node actually. So I will say my name node is here, my job tracker is here, my secondary name node is here, and then my first data node will come here, then second data node, then third data node, then fourth data node, fifth data node, then sixth data node, then seventh one, then eighth one, and then ninth. Okay, so I can say that I'm having this 12 node kind of cluster, and each of these machines are fitted into one rack. So I will say this is my rack 1. Okay, this is my rack 1, this is my rack 2, and this is my rack 3. Okay, in general production basically we do have only 2 racks, but just to to tell this concept to you, I'm using 3 racks. Okay, each of these racks are now connected to some router. Okay, and these racks are like having kind of certain IP address ranges available to it, and out of those IP address range basically these data nodes or name node, whatever machine that are those are installed or those are the part of that particular rack will have the IP address from that particular range that was assigned to this rack. Okay, now when you say when you write the data into HDFS, basically, let's say I will say block 1, the first copy. Okay, so first copy of any block, how it is getting written. So the rake awareness concept, or this rake awareness is basically generally a kind of policy being written in Python. Okay, though it is very easy to configure it using Ambari or Cloudera Manager. Okay, you just need to create some rack number, rack names, and basically assign it, and if, whichever data nodes you are having, just assign those data node to the whatever racks you are having. Okay, so basically behind the scene there is a policy created, and as per that policy what will happen is, let's say when the first copy of block is getting written, so I will say blk1, that let's say that blk1 will come here. Okay, blk1 will come here. So that blk1 has come here on data node 2. Now the second copy should go where? Okay, so from here, from this point onwards, this policy will come in picture. So the second copy of this block 1 should go into some different data node, that is perfectly fine, but then to make it more redundant, to make it like more redundant, to make it more fault tolerant basically, it should not go on the same rack. Okay, so the second copy of this block 1 should go into some different rack. Okay, so I will say on the rack 2 this blk1 copy has come. Okay, and to make it more fault tolerant, the third copy should go on to the rack 3. But in most of the production, basically we do have two racks only, rack 1 and rack 2. So the third copy should come. So the third copy should come in any of these racks, rack 1 or rack 2, but not on the same data node. Okay, so I will say it should come over here, BLK1. Okay, so this is what is called rack awareness. It means that the blocks, when the name node try to put the block, it should first check how the rack topology is assigned to the data nodes, or which data node is a part of which rack. And because the thing is, if the rack failure is there, okay, we still should be able to find some copies of block on the other rack. Okay, so to make it more fault tolerant, this is how actually what is the rack awareness concept, or whatever is the rack awareness, that is how actually it works. Okay, though behind the scene there is a script that gets generated whenever you create this policy, and both name node or job tracker and in yarn, basically resource manager. So resource manager and name node, they both refer to this rack awareness topology or rack awareness policy, and depending on that only, name node will choose the data nodes to be more fault tolerant. I mean, to be more fault tolerant, basically it chooses the data node depending on this rack awareness policy to place the copies of block. So first one chosen randomly, second one will be chosen on the other rack, and third one should be in any of the rack but not on the same data node. Okay, so one data node should not have same copy of block multiple times. Okay, so one data node can have only one copy for that particular block. The second copy should definitely go to some other data node. Okay, so this is what's called rack awareness.
So this rack, what you are talking about, is it everything they will be doing in the same cluster, is it?
Yes, it is per cluster.
So this job tracker also, it is a kind of data node, is it?
Basically, it is a machine where we install job tracker, and mostly where we install master, we won't install any slave part. Okay, so in job tracker, there's task tracker is the slave part. Just like in the name node, data node is a slave part, name node is a master. In job tracker, task tracker, job tracker is a master, task tracker is a slave. So what I'm trying to say here is the name node is a separate machine, job tracker is a separate machine. There we won't install data node daemons. Okay, so data node, we will say that data node 1, data node 2, 3, 4, 5, 6, 7, 8, 9. There we will install data node daemons. Okay, and name node and job tracker or name node or resource manager will refer rack awareness topology in order to place the block. That is what is called block placement policy. Does it answer your question? And yes, these are all the part of same cluster. I mean, these are not separate cluster. Rake 1, Rake 2, there are like these two rakes are in the single cluster.
What is the rationale behind this? Because the original concept that you explained, it's very clear. And now we just take the data nodes into three different racks, and make sure that each rack will have some data nodes, and the policy has been built to save the block in different racks to ensure what? I mean, what is this whole idea behind this?
Yeah, see, the thing is, these data nodes, they are like, being not installed as a independent machine. I mean, if you go to your company, any company, basically, they are having some server rooms, right? If you look inside it, these are like how they are getting fixed, into some cluster, so one rack, it's like, you can just try to Google it out. You will find some pictures of rack, right? In every rack, you will fit some server into. One server is having all like hardware, motherboard, CPU, RAM, number of processors, hard disk, everything is there in the single one particular server. That server itself is getting fitted into the rack. Okay, and there are like kind of two racks, such two racks there in your Hadoop cluster, mostly in production. Each rack, so to have the redundancy in master also, basically not redundancy, but even to make it like, so name node is going to be installed in one rack, and job tracker is going to be, or that server or that particular machine is going to be installed on the other rack. Okay, so mostly let's say there are two racks. One is in which name node is one master rack, one master in one rack, and job tracker is master in the second rack, and then remaining servers, they are like they are tend to be data nodes. So this rack awareness is concept only. I mean that is a policy basically generally. I mean see, if you keep all the blocks copies in the rest, let's say rack 1, okay, and if rack 1 goes down, basically what will happen is, I mean, you do not, and rack 2 is let's say up and running and is still serving the request basically. So there is no you know all the blocks, since they are in rack 1, the copies of all the blocks are in the rack 1, and if rack 1 is down, basically there is no point or no way that you will retrieve the data. So you need to wait for that rack 1 to come up and running, so that you start serving the client. So just to understand basically, since we do have job tracker on rack 2, if suppose rack 2 has gone down, okay, so job tracker, okay, I mean no analytics will run because job tracker rack is down, but name node still is there, so you can still serve the reading and writing requests from the clients, different clients. What happen if you have all the copies of, let's say, block 1 on the rack 2 that has gone down? Then in that case, still your name node and the other data nodes are up and running, but since that block 1, all the copies are there in the rack 2 that is down, you cannot serve the request for to any client who will actually try to read the file whose block, which actually pertains to block 1. So just to make it more fault tolerant, this is how actually the block placement policy will be done, or will be actually chosen, and that is being taken care by rack awareness. Okay, so it's like kind of a policy or concept, or like kind of a small script that will be read by both name node, job tracker, or if it would be case in Yarn, it would be resource manager, in order to check that, okay, these in this rack, these are all the data nodes. So let's say if first data node is chosen from this rack, then the next data node should be chosen from the other rack. Okay, if that other rack is there, so that the copy should be more distributed among the cluster. Are you getting?
Yeah. So that means the rack information will also be get stored in file system, is it?
Yes,
File
yeah,
system.
not exactly in the name node file system. Yeah, but independently there is a file that will be referred by both name node and other masters.
Okay. Okay.
Okay. Now, let's talk more about the Hadoop distributed file system in terms of how does it connect to the local file system. Ultimately, what happens is, when you talk about Hadoop distributed file system, is it a real file system? No. Why? Because ultimately it again requires a local file system, because the thing is, it requires operating system, okay, to be installed, and then an operating system itself is having its local file system. So let's say we installed the Hdfs on Linux, and Linux is having its own file system. So I'm saying that my local file system, LFS, local file system, block size is 4 kilobyte. One second. Local file system, so I will say 4 kilobyte. Okay, and my Hdfs block size, Hdfs block size is 128 MB. Right now, we have seen that in local file system, if we store only 1 byte of information, the remaining bytes in that particular block is going to be wasted. Okay, we cannot use it. We have seen that if we create a text file, let's say, and we have just written 1 or 2 letters in it, so it will occupy that many bytes in the block that is associated with that file. Okay, so the block size is always 4 kilobyte in local file system. Okay, and the remaining bytes in that particular block is totally waste. I mean, you cannot use the remaining bytes of that block to store the information from some other files. Okay, that is the concept of file system. How does it affect the HDFS, Hadoop Distributed File System. So 128 MB is very large block size that HDFS is dealing, right? Now suppose if I store only 1 byte information in 128 MB of block size, what will happen to the remaining space? Okay, so we just need to understand that how it is connected to the local file system, because ultimately HDFS is said to be an abstraction on your local file system. Okay, it's not a real file system, it is still hangs over your local file system. Okay, so local file system is your real file system handled by your operating system. On the top of it we install HDFS. Now HDFS is just like, you know, hovering over your local file system. Okay, so it is just kind of a lens, okay, through which you are actually looking at to your local file system. Okay, so HDFS is just like over the, so at the base this red block, I can have multiple 4 kilobyte of local file system blocks. Okay, and then I will draw one HDFS block on the top of it. Okay, so one HDFS block may have multiple local file system blocks under the hood, right? So if you divide 128 MB divided by 4 kilobyte, that many local file system blocks come under one HDFS block. But still, can I use 128 MB or can I use 128 MB of block to store only 1 byte information? Can I store 1 byte information in HDFS file system? Yes, there is no restriction on that. Okay, you can store any number of data starting from 1 byte to whatever number of bytes you want. In that case, what will happen is the interview question or some question would be like this: if I store 1 byte of information in 128 MB of block of HDFS, what will happen to the remaining space? So the answer would be, you store only 1 byte in the local file system. Okay, it means that the local file system, now let me change again the color, so this blue circle, the blue square will tell you the HDFS block, the red square will tell you the local file system block. And now I'm just marking this green to be the data. So let's say this 1 byte has come over here in your local file system. It means that your 4 kilobyte block is on the local file system level, LFS level. It is getting, you can say reserved. Okay, now this particular block cannot be used to store any further information. Okay, so when you use 1 byte information, when you store 1 byte information in your HDFS block, that is actually 128 MB of block, that is this blue square. Okay, it will just represent, this particular block. I mean, what I'm trying to say is, at the bottom level there is a local file system blocks. Okay, and it is true that if you store only 1 byte information in HDFS 128 MB, ultimately it is going to occupy only one block at the local file system level, right? So only that much storage will be wasted. Rest is still will be used by any other file to store the file. So basically you are just trying to see that this particular since it is abstraction, it can just represents to be the 128 MB of block size that is actually pointing to only one block of your local file system. Okay, so this will shrink and just point to the one particular block at the red block on the local file system. So ultimately it is when you actually see through any name node. When we install, currently it is not available to us, the HDFS file system, but when you look into the files of HDFS file, though it will tell you that it is actually represented by 128 MB of block size, but ultimately at the bottom level, ultimately at the local file system level, that much storage is not going to be used, because that much data is not there at all in order to store in that 128 MB of data. 128 MB of block size. So this particular block size, it is just the representation. Okay? It is only for the representation. Okay, and this is not actually the real one. It is just like the abstraction over your local file system. You can have one particular block, okay, of HDFS to point to 128 MB divided by 4 kilo, let's say 1000 blocks has come. So all those 1000 blocks will come under this 128 MB. But ultimately, if you store only 1 byte information in HDFS, at the bottom level only 1 byte information will be occupied by within one block, and the remaining space of that block, which block? Local file system block. So that is the wasted. So ultimately, if you store only 1 byte in this 128 MB, what is the total waste? So 4096 minus 1, that is equal to 4095 bytes is actual waste. Okay, the remaining blocks under that HDFS still are like available for storing the information from the other files, for the other files. Okay, so ultimately this HDFS is not a real file system, it is just the abstraction over your local file system. Ultimately, whatever data that you're inserting in, or whatever data you're storing in HDFS will ultimately go to your local file system for actual storage. Okay, because HDFS is not a real one. Okay, it does not hold the data over there, it will just allow that data to be ultimately written into your local file system. Okay, so there is a connection between local file system and an HDFS. Okay, so you will sum up the number of blocks from the local file system in order to make your one HDFS block. Okay, but that one HDFS block will not always be actually of 128 MB. Okay, it may vary depending on what actual size you are storing. Okay, so if you are storing only 1 byte information, only 4 kilobyte will be represented by that 128 MB of data from HDFS, but it does not actually use all that 128 MB. Okay, so here most of the guys can get confused, and if you ask that, okay, since they will try to apply the same logic of your local file system, that okay, if 1 byte you store, out of 4 kilobyte 4095 byte is waste. So similarly, if you use only 1 byte in 128 MB, so 128 MB minus 1 byte will be the waste. No, it is not that case. Okay, so it is only the waste at the block level of local file system. Okay, so you can store 1 byte of information, multiple 1 byte information as a, like you can, let's say 100 files of 1 byte each can be stored on HDFS. So it means that at the bottom level they utilize only 100 blocks of local file system. Okay, so now what happens, suppose if you store, one second, if you store, let's say 8 kilobyte of information in HDFS. So if I ask you to store 8 kilobyte of file in HDFS, what is the waste? Basically no waste. How come? Because this 8 kilobyte, though it is getting represented by 128 MB of block of HDFS, but ultimately it is going to be stored on your local file system, and in the local file system the block size is 4 kilobyte. It means this 8 kilobyte is going to be split into 4 kilobyte, and those two blocks will be completely filled. It means that there is no wastage of space at all. Okay, so ultimately when you try to look out for the waste of space while storing the information, always look at the block level of local file system, not on directly on the HDFS 128 MB, because it is not a real file system, it is just the abstraction over local file system. It will point to the local file system blocks with that representation of 128 MB. Are you getting me? This needs to be clear further. I mean, since it is not a real file system.
No, I understood.
Yeah. Okay. Good.
So basically, even though we say it as 128 MB, but it actually depends upon the local file system where we store the information.
Correct.
If it is 1 byte or 8 byte, it depends upon what is the local file system we have, and that will be the wastage that depends upon for each block.
Correct. So when I say,
so how about so when you say 128 MB for each size, each block size, so with respect to HDFS, then there is no wastage at all. It all depends upon the local file system.
Correct. Very correct. The wastage will be counted on the local file system level only. Okay, and here most of the even like experienced guys may get confused. Okay, if it is 128 MB. Now the second question comes, like if it is not a vested on the HDFS level, but again HDFS blocks will have its own unique identifier. It means that this 8 kilobyte, right, when you talk about this 8 kilobyte data, right? That is pertaining to, so let's say I'm storing this from file.txt. I do have file.txt that is of 8 kilobyte, but this 8 kilobyte will be stored in my Hdfs using only single block, right? Only one, let's say I will say this is block 1, blk1. Only one unique identifier will be associated with this 8 kilobyte. But then internal, when you go further on your local file system level, there would be two separate block IDs will be given to it. Why? Because on the local file system it will be split it into two 4 kilobytes chunk. Okay, but then we don't care. I mean, we are dealing with the Hdfs level. We are dealing on the Hdfs level. Okay, so you will be asked like question. You will be asked like question. Okay, if what's if I do have one. I mean, I generally ask that question. What will happen? Suppose if we are saying okay. So in Hdfs, if I allow one particular block to be used for 8 kilobyte, the remaining space will still be used by the other files to be stored. But is it possible that this particular blue square, I'm saying that this is an abstraction over local file system. It is a Hdfs block, and this Hdfs block may have one unique identifier, I will say blk1. Okay, out of which I have used this much space, that is 2 bytes, for storing 8 kilobyte of one file, that is called file.txt. Now I do have one more file, that is, let's say, file1.txt, which is of having one more 8 kilobyte of data in it. Okay, can I assign the same block blk1 to the file 1.txt also, that may be used to store over here? So this is these two blocks on the local file system will have file1.txt. These two blocks from the local file system from the file.txt, simple, not file1, file.txt. So can it be possible that one particular block of Hdfs having the same ID can be used to store two different data from two different files? Is it possible? No. Otherwise fs image will get confused. Okay, because file.txt is having, let's say, text data, and file1.txt is having, let's say, image data. That is completely different data. Okay, and if you are allowing this to happen, then you definitely create a lot of mess in your file system, that no one knows that which to read, what not to read. Okay, so it means that for this particular part over here, the block ID is different. So I will, let's say, this would be block 1, but then this part should be definitely have some different block ID. Otherwise, it would be a lot of mess. So I will say it should be blk2. Okay, so you need to clear this concept, right? When we talk about Hdfs, it is completely the abstraction on your local file system. It's not real file system. Everything is manageable under it, so that there should not be any confusion. Even though we are treating it as a real file system, but it is not actually a real. Okay, so this is the second question where most of the guys get confused. I mean, I generally ask it. If I ask them, so if you talk about a single block of Hdfs, it should have one block ID associated. Everybody say yes. Then I pose second question, that suppose if you are using that block in order one block, because 128 MB you have assigned one block ID to it, and in that 128 MB you are storing many smaller files from the different files. One is image data, one is text data, one is PDF data, one is Excel data. Then how come when you start analyzing that particular block, what to choose, what not to choose? Okay, so this is the second concept, where though it is still not filled 128 MB, but then since it is from different files, that particular block, both blk1 blk2 will be having separate identifier, and this particular block 1 will still be treated in Hdfs as 128 MB of representation. This also will be treated as 128 MB of representation only. It is not real. This is just the representational way how the Hdfs is dealing with the local file system under the hood. Okay, so be very, very clear on this concept. Otherwise, it is seriously, I mean, so currently just listen it, when we actually install the HDFS and try to see, and we will store some very smaller files and try to see that how HDFS will show us on the web and on the front end, that basically, okay, this is the file, this the actual size of the file on HDFS is this, its HDFS representation is 128 MB, but its actual size on the local file system is something else. Okay, so Hadoop is built for larger files, so we can say smaller files of Hadoop is built for a smaller number of larger files. Okay, it is not built for larger number of smaller files. Try to understand this. Okay, so Hadoop is always perform very good when you store very smaller number of very large files. Okay, so large file, even terabyte of file you are going to store, that will be always very very good at performance. But suppose if you are having very very larger number of very smaller files, like 1 byte files of very large number, thousands of very 1 byte files, or to 10,000 of 1 byte files, it is always going to waste your space, because under the local file system it is always be a waste, right? So if you go to the local file system and try to see that, okay, if you are trying to store 1 byte of various large number of 1 byte file, basically it is going to waste 409 byte from each of the blocks at the local file system. Okay, so the slogan of Hadoop is always store a smaller number of larger files, not the larger number of smaller files. Getting?
Sure. Okay. I have some few queries with respect to this file.text and file1.text.
Okay.
So just clear me if I'm wrong somewhere. So when you say 128 MB of RAM, 128 MB of space is used for each block. So the first 8 KB has been stored at the backend in the 2 blocks of local file system.
Correct.
So whatever you have highlighted in blue, that is the actual 128 MB.
Yes.
Which is been blocked by HDFS file system, say for example.
Yes.
Right. So when I say the next file1.txt comes in, so I will not be using those blocks at all. That is what you're saying.
Yes, correct. So ultimately, this blue square, it is just a representational way. Okay, it can be shrink, it cannot be expand more than that, but it can be shrink to fit. Not shrink. Basically, you are just seeing your local file system through the lens of HDFS, where since it is just a lens, I mean, you can, if you bring it down, the letters will be more bigger. If you pull it up, the letters will be more smaller, kind of thing. So it is just like fitting itself hovering over your local file system in order to just adjust itself. But each of the block on the HDFS level is represented as 128 MB on the HDFS level, but actually in the size at the local file system, no, it is not like that. Okay, so we represent even 8 kilobyte of data or 100 kilobyte of data through 128 MB of block sizes. Okay, it is just a representational way, it is not the actual way. So maximally we can have 128 MB at the local file system to be mapped directly to the 128 MB block of your HDFS size, but still, so this is one way, that is the boundary case. Then you do have 1 byte of information stored in the in HDFS still be represented with 128 MB of block size. So that is the boundary case. In between 1 byte to 128 MB, yes, everything you can store will be still represented by 128 MB of block size in HDFS. So this is again very theoretical. It is very difficult to create that picture in mind, but if you understood that, very good. Otherwise, when we see it practically, I mean, I will when we install the things, when we install HDFS, when we store the data, so we will store the data of 128 MB of file also. We will store 1 byte of information also, and we will try to see that how HDFS will represent both of that particular files being represented by 128 MB of block size.
Yeah, I understood, but I just want to be very clear on this.
Yes.
So when you say file1.txt, that cannot go in the first block, block 1.
Yes, it can never go.
Correct?
Yes.
Okay, then when the file 2 comes in, then it will go for another block of 128 MB.
Yes.
But then the backend representation that could be so say for example if you represent it in the screen,
Mhm.
it will be in another 128 block where the
Yes,
file 2 will be stored.
yes, yes, yes.
So the remaining spaces of local file system of that 128 MB
Mhm.
will be reutilized for some other purpose, or it will be still
Yeah,
will
it will
be
be
blocked
reutilized.
for
It will
this
be. See,
particular.
the thing is ultimately, uh, if you do not have 128 MB at all, I mean, because the thing is, you seldom have 120. I mean, to do some local practice, basically, you may not have 120 MB. You will have some kilobytes of file. When you store it, basically, you can, yeah, store in HDFs, no issues on that. But ultimately, those are going to be represented by individual 128 MB blocks. Block identifier also associated with the file. Sorry, each block level we do have a separate block identifier. Okay, so depending on what data size you are having, so ultimately HDFS block identifier is for that. So we do have one block identifier associated with this particular file because it does not even have one block completely filled in on HDFS level. This file dot this particular block of this particular, because it does have only one block. Are you getting me? So file one dot text and sorry, file dot text and file one dot text. One second.
uh, to the backend local file system. So that means it is still a wastage only, right? If it is not used, you're saying that it is just a representation. If that means that it is not holding the entire 128 MB, but it is represented. Only the 8 KB is stored in two blocks. The remaining blocks
Or
at the
can
back
be
end that
yeah,
can be stored.
yes, that can be
That
still used for storing the other information. Correct.
other information for another block.
Yes, another blocks or another files, whatever you're saying.
Mm. So basically, local file system that will not have any wastage. Still,
Yes,
that will be utilized for another blocks.
correct. Very correct.
Okay. So it is just a representation from HDFC side that it
Yes,
is 128 MB. That's all.
yes, that's all. Okay, so
Okay.
this concept is very great. I mean, uh, most of the guys easily get confused. Okay, even the experience, I tell you that 3 years, 4 years, 5 years, when I take into easily get confused on this. Okay,
Okay. Fine.
so that's it for today. Let's meet tomorrow, and tomorrow we will start Java.